Here's project 2, video 2, the one in which I coded up. Type in edit. Make this small enough that you can see it. And make up my function. The return equals plot v2, and it's capital V, capital R sub 1, capital R sub 2, and I got to end a function, and then the meat of it goes up in here. Let's see what we had on our plan. The code outline given those guys. R3 is linspace of that. I actually don't remember how that works. So let's make x equal linspace 0, 1, 0, 11 values. And it goes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so it's like 10 values and then the 0 value. That's why I always have that one extra value. If you think of it as, why not just 10 values? So that does seem to be working. Switch over to the editor and go R3. So it's an array equals linspace of 0, 10 times R2, 101. See, it looks smooth enough with 100 values, and that was supposed to be a 10. 10 times R2. I think I'm going to try putting a semicolon there. And then what I have, I'll just copy what I already worked out. Calculate R23, which is that. R23 equals 1 divided by 1/1/ R2 plus 1/R3. Now spread that out a little bit. And then I gotta think about this. R3 has got 100 values, so that division is not going to work without a dot. The dot says, I get dot slash. Now 1, dot slash. Concerned with the 1 being like 1 point. I don't want the decimal point to be associated with the number there, so I chose to put a space. Doubt if that makes any difference. This is just a pure number. I do this, divide that by an array, and I get an array of 100 values, and then I add a value to each one of them. So I don't need a dot there, but I do need one there, because now this thing in parentheses is an array of 100 values, and I want to divide it on an element by element basis into 1, not try to take the inverse of it, which I think is what the 1/ without the dot does. Okay. Next, RT. RT equals R1 plus R23. Okay, this is going to add the value R1 to each element of array R23, gives us 101 values of RT. That shouldn't be a problem. So R1, R23. Okay. Next. I is V over RT. Capital I equals V/RT. Okay. RT is 101 values. Whenever I got an array in the denominator, I need to use the dot slash. Okay, I'll try a semicolon there. Next, that was I. V2 is I times R23. V2 equals I times R23, semicolon. Now I is an array of 100 values, R23 is an array of 100 values, so we're trying to multiply two arrays, and I need the dot star to tell it to do it on an element by element basis. And then plot, you go x comma y, so R23 comma V2 to get a graph of V2 versus R23. Alright. Let's see if we can predict a little bit what this is going to look like. If R3 is 0, then this is infinity, plus that gives infinity, divided into 1 gives 0, so R23 will be 0, and so the voltage across, then it's acting like a straight piece of wire, so the voltage would be 0. So it should start out at 0, and then see if we can figure out what goes on here. As R3 gets bigger, this whole combination gets smaller, so the reciprocal of it gets bigger. So R23 gets bigger as R3 gets bigger, and therefore RT gets bigger as R23 gets bigger, and so I gets smaller, and then we're multiplying it times something that got bigger, so it's kind of hard to say exactly what's going to go on there. So I think for checking the work, I really need to take a look at this. I mean, I should have an idea what the graph looks like when I get done. So I want to do some back substitution. V2 is what we're plotting. V2 is I, which is V over RT, times R23, which is 1 over R2 plus 1 over R3. So V2 is equal to V over R1 plus 1 over R2 plus 1 over R3, 1 over all that, times 1 over R2, 1 over the reciprocal of R2, plus 1 over the reciprocal of R3. So this probably would have been easier if I'd have left it as R23 for a while. I think I'll change that. So this is, let's keep that. As R23, and this is V over R1 plus R23 times R23. V2 is equal to V over R1 plus, oops, let's give me a little bit more room here. I'm going to divide top and bottom by R23, so I got R1 over R23 plus 1. And I think I can see it from there. As R3 increases, R23 increases. As R23 increases, this term decreases. So the denominator gets smaller, so V2 increases. So it starts out at 0 and increases from there. As R23 goes to infinity, R23, no, as R3 goes to infinity, R23 just goes to R2. So V2 max equals V over R1 plus R2 plus 1. I guess maybe I should make that more obvious to you. If R3 goes to infinity, this goes to 1 over infinity, which is 0, and we just have 1 over R2, which is just R2. So R23 goes to R2 in the limit as R3 goes to infinity. And that's the max value that V2 will ever take on, because it keeps getting bigger as R3 gets bigger. And I think that's just R2 divided by R1 plus R2 times V. So V2 max is that. So it's whatever fraction R2 is of the total resistance is what the voltage times V, whatever that fraction is times V, is what the maximum value of the voltage goes to. So if I pick like R2 is equal to 25 ohms, 75 ohms, and 25 ohms, I'll have 1/4. So I'm going to go, I want to test it that way. Or test if V equals 10 volts, R1 equals 75 ohms, and R2 equals 25 ohms. V max is equal to 2.5 volts. So that'll be a test case for me. Plus, I want to make sure it starts out at 0 and it's increasing. And I didn't really take the derivative of this to see what the slope was. But there you go. We'll see if the rest of the stuff works. So where was I here? Oh, save it as plot V2, and then try running it. And run. Oops. I just type in plot V2 of, I said 10, comma 75, comma 25. Let's see if I get a graph. That's sweet. I do get a graph. I claimed it was on its way up to 2.5 volts. That's kind of odd that the maximum value there is 2.5 volts. But let's try. Hopefully I remember to switch this back. But let's make it go up to 100 times R2. 100 times R2 rather than just 10 times R2. See if it, it's really as it approaches infinity, we're going to go to 2.5 volts. So let's make it go up to 10 times that other value. So if we do that, sure enough, it's never goes beyond 2.5, and it seems to be getting very close to 2.5. If I try 1,000 times that, so 1,000 times R2. I'm a little surprised it doesn't approach it asymptotically, but I don't know. I didn't really look at it mathematically, so there's no reason I should expect it to. So let's run it, and sure enough, it goes right up to 2.5 and stops there. I got a little kink in there, so that suggests that something funny is going on. Let's try switching that back. That was supposed to just be 10. I'm going to try just 11 values. Now I expect kinks, but let's see if there's anything that tells me what's going on here. So, steps of 11. So it looks like a little bit of a kink right there. Now, you can't see where I was pointing. Kind of kinky right in there. So it's almost like it's two straight line segments, which seems a bit odd. I'm going to bump that up to 1001. It has something to do with not taking enough data points. They're not, not evaluating enough different values. That I don't have to change. That's just supposed to make things look smoother. And it actually does. So for whatever reason, I would say 100 points wasn't enough to make this one look smooth. I bump it up to 1,000, and I'm not seeing any kinks whatsoever. It does look smooth. So I think I'll leave it at 1,000. Alright, so it does seem to pass my checks when R3 is equal to 10 ohms. I guess there is some question there. Am I really going up to 10 times R2? I go up to only 25, and R2, let's see, was 75. I'm not seeing the graph go up as high as it should, so looks like there's some kind of mistake there. Plot R23. Oh, it wasn't supposed to be R23. It's supposed to be just R3. Yeah, I got a feeling I'm not going to need that many points here. So this is a function of R3, now it's a function of R23. So save that. And then we go from 0 up to about 25 ohms. And as far as I'm concerned, that doesn't make any sense because R2 is 75 ohms. Let's make sure I got we're right. VR1, R2, so it's the second one, or the very last argument. 25 ohms is R2. So I should be going from 0 to 250. And I seem to be going from (0 to 25). So I'm going to take just 11 values to debug it, and I think I'll print that out. So I saved it. I'm going to close that and run it. Plot V2, 10 volts, 75 ohms, 25 ohms. And that time it worked. Went up from 0 to 250 ohms. So I think the problem may have been I graphed it once and then I redid it while the figure was still open. This time I've definitely closed the figure. I'll save that, try running it. You know what, it is asymptotically approaching the 2.5, so there's out to 250 ohms. Not all that close to 2.5 though, so I want to try it. First off, I better get rid of that printout where it's printing everything, so I put the semicolon there. I took it off to debug, and then I think I want to take that out to 1000 R2. Not very many steps, but see if it comes closer to the, I think it's 2.5 is what we were expecting. And yeah, sure enough, goes right up to 2.5, so it asymptotically approaches it. That might have been a little overkill. Let's try it with just going up to 100 times R2. And sure enough, asymptotically approaches 2.5 volts, and that goes from 0 to 2500. And now to fix it so that it's what we were asked to do, just go up that far. Control S to save it, run it. Looks like a beautiful graph. It looks kind of like one of those 1 minus exponential functions, but it's not. It's I actually have a pretty good handle on what it looks like based on this, not the max, but this expression right here. I just have to write R23, or maybe 1 over R23. I got R1. You can think of this R1 times 1 over R23. So if I wanted to see a little bit more what it looked like, I could write this as V, in terms of R3 itself, R times 1 over R2 plus 1 over R3. So I've written it as R1 times the reciprocal of R23, and then plus 1. So that's the function that I'm graphing. V2 as a function of V3 with V, R2, and R1 all constants. So it's a piece of the denominator, and it's the reciprocal of R3. It makes up a piece of the denominator. I guess I could say that's R1 over 1 plus constant, R1 plus R over R2 plus R1 divided by R3. So you can see that the R3 is in the denominator. 1 over R3 is in the denominator of a fraction, and that's all multiplied V, by the way. Okay, so it's not 1 minus an exponential, and yet it kind of looks a little bit like it. The graph does. So based on the fact that it goes up to 2.5 when I was expecting it to go up to 2.5, let's take one more shot at the way this works. The maximum value is that if I make R1 and R2 the same, it should go up to half the voltage across the seat of EMF. So I'll make those two the same. I'll choose to call, let's go with 12 volts instead of 5 volts. So if I go like 12 volts, make that 750 ohms and 750 ohms, it should go up to 6 volts. And indeed, it does seem to be asymptotically approaching 6 volts there. So I have tested it in a couple of cases. So I've programmed it up, tested it in a couple of cases. I still have to do the documentation. We'll save that for video 3. This ends video number 2. The coding up the MATLAB function for project number 2.